Algebra students, today we're looking at this assignment called Find Best Fit Curves. And there are notes that go along with this lesson, but instead of going over the notes that we'll do in class, I thought let's just jump right into the assignment. And let's do questions 1 and 2 from the assignment together. All right, so question 1 here says, enter this data into a table on Desmos, and here's the link, and then make a prediction. Which of the following functions do you predict will best fit the data? And it gives us 3 options here: linear, quadratic, or sine. All right, well, let's start with, first off, how do we put this data into a table on Desmos? Let me show you. I'll click the link here. To enter a table on Desmos, you're going to start with this plus button right here. We hit this plus button, and there's a choice that says table. And you want to make sure that your table starts with an X1 and a Y1. And then we're literally just going to start typing, okay? For January, we're going to put a 1. And for the number of hours of daylight, we're going to put 9.4. And we're going to just start going down the list. There's 12 months in the year, so we're going to go down the list and start filling these in. And voila, I went ahead and filled these all in. If you need to pause your video and fill those in, that's fine. But then the next thing is I want to actually be able to see my data points, okay? On my viewing window here, I don't actually see any of the points I put into the table. Now, you could try just zooming out. And in this case, you could actually zoom out and kind of manipulate the screen and work it that way. Or a little bit more precise way to get the exact window that you want is you can click on this wrench up here in the top right corner and change the x-axis and the y-axis manually, okay? So like my x-axis, I know I want to go from like, there's 12 months in a year, so I could go from 0 to 12, or yeah, I'll actually leave it like that. Go from 0 to 12, and I can call this a month, if I can spell month, okay? And then my y-axis, I know the amount of daylight it goes, you know, the lowest is like a 9.4. The highest is a 15. Okay, so I could manually go in and, you know, I'll just make it, there's 24 hours in a day. I'll just go from like 0 to 24. And these are hours of sunlight. Okay, so sometimes I'll even do that, and then sometimes I'll even like zoom out once. So you can either use this zoom in, zoom out feature and click and drag to get the window you want, or you can do it manually with this wrench and set up your numbers the way that you want it. Okay. Now that we have this done, now I need to make a prediction. And think about it, you know, my choices were linear. You can imagine like trying to draw a straight line through this graph. Okay, I can tell you right now, linear is going to be a terrible choice. There's no way you can draw a straight line that's going to go through these points. You can see how it has a curve. And so I think my best options are either going to be quadratic or sine. You know, if you remember what the sine wave looks like, quadratic makes a parabola, sine makes a wave. I'm looking at this thinking, you know what, that almost looks like it would make a wave. And the fact that it's kind of cyclical and it's going to repeat year after year, I'm going to, for my prediction, say, I predict that it's going to be the sine function is my prediction. Okay. Now, so that question is really an opinion question. You can't get it wrong, but really put some thought into it, which shape you think would fit the data the best. Now, as we go down to question 2, I'm going to show you how to do this. Perform a regression test for each of the following general functions and select the corresponding r-squared value. So let's start with linear. I'm going to perform a regression test using the linear function. What I'm going to do is I'm going to go down to the box below the table. And so the linear formula is this: y equals mx plus b. What I'm going to actually type in, it's going to be similar, but with some slight differences. I'm not going to type y, I'm going to type y1. It's going to put a little subscript 1 after it. And I'm not going to hit an equal sign, I'm going to hit the squiggly sign. Okay, it's right below the escape key. You hit shift and then it's right below the escape key. And then I'm going to type mx, but instead of just typing x, I'm going to type x1 and then plus b. And what's going to happen is Desmos then will draw what's called the best fit line according to the data. And I can look at this. My r-squared value, this is what it tells me how this is what tells me how strong the correlation is between these data points and a straight line. And look how low this is. It's 0.0039. If you move the decimal two places over to write it as a fraction, this is 0.4%. Okay? And so when we go to question 2, it says select the corresponding r squared value. That's 0.4%. 0.4% is 0.004 as a decimal. That's extremely low. This is saying that our data points do not fall into a straight line, even relatively close to being a straight line. Linear is a terrible fit for the data points that we have. Okay, so now I'm going to do the same thing with the general form of a quadratic function. Okay, so I don't want to erase this yet. I want to hold on to it, but I'm going to actually turn it off by clicking on the colored line. I can turn that off. And down in the next line, now I'm going to go y1 squiggly line, and I'm going to type in the quadratic general form. It's a times x, and instead of an x, we're going to put an x1 minus h squared plus k. All right, and so this is, I'm literally just copying this down right here. And then the only difference is instead of the y, I'm putting a y1. Instead of the x, I'm putting an x1. And then instead of an equal sign, I'm putting the squiggly. And as long as my table leads off with an x1 and a y1, look at what happens. Doesn't this look so much better? This time it's drawing a parabola through the points. And man, you can tell right away that's a much better fit. And the r squared value really says this as well. Here the r squared value is at 0.9404. If I move my decimal two places to the right, that's 94%. So for quadratic, the fit is much better. For quadratic, the fit is 94%. Okay. Now I'm going to do the same with the sine. Now I want to point out one thing. Here, our sine function, I added one letter to our sine function here. It's this letter B. When we did general form of a sine wave on the board in our notes, we didn't put this B here. This B is kind of an optional letter, and in this particular case, the B is going to help us. So let me turn off my parabola now, which has a 94% correlation. And now let me type in this last one, the sine wave. Y1 squiggle A times the sine of B x1 minus h plus k. Okay, and again, remember, make sure you type this B in here. This is something that was not in our original formula. But man, my first instinct is wow. I mean, that's almost perfect. It's almost 100%. It's almost a 100% match. And zooming in to look. Now, some of the points are like slightly off. And see, this makes sense. We're talking about how much sunlight we get based on the month of the year. And you would think, well, that is cyclical. That goes in a wave. It's going to repeat itself year after year after year. So a sine wave would look great. Look at this r squared value, 0.9986. If we move our decimal two places to the right, that's 99.9%. This is my clear-cut winner. The best way to model the length of sunlight that we get based on the month, it's the sine wave. Okay, so sine is our best fit. Okay, now one last thing I want to show you. So question 3 starts with a new chart, but I need to show you one last thing that's extremely important. We should now be able to use our graph to make predictions about the future. Okay, so let's say this question isn't here, but let's say there was a question that asked, hey, what would you predict for the following January? Okay, what would you predict for the January following this year? In other words, what would you predict for like month 13 if there was a month 13? And here's how you do that, okay? Once you pick the curve that fits your data the best, in this case it was the sine wave, what you can do now is you can now trace this curve out past the data that you already have, and you can start making predictions about what would happen in month 13, okay? I'm going to click and drag here. Let me zoom in. I'm going to click and drag on my graph until I get to like month 13. And in month 13, I would predict there's 9.3 hours of sunlight. And I could predict month 14. That would be the following February. I could predict month 15. If you ever have to make predictions about the future, you're going to highlight the graph that fits the best, and you're going to click it and drag it, and you could drag it to month 13 or 14 or 15 or 16. Drag it to wherever you want to make your prediction, and you can now make a prediction about these future months. And this little idea of being able to click and drag along your line, that's going to help you in some of the questions you face further down the road. Okay, so that's all for this video. Best of luck on this assignment, and take care. Bye.